Now let's discuss scalars and vectors. So scalar physical quantities are those quantities which require only magnitude to get defined. For example, mass. Okay, mass is a kind of scalar physical quantity. So if we want to add two masses, it doesn't require any vector addition. It can be added with just a simple algebra. So therefore, we can say scalar quantities follows simple algebraic additions. They doesn't require any direction. Only magnitude is enough to define scalar physical quantities. They are always positive or it may be zero. Why positive? Because they are following simple algebraic additions. They are never negative. Okay, so these physical quantities are called scalar physical quantities. I have given some examples. In these examples, you can see like work is negative or positive, but actually that work, the negative work is not due to its direction, but it is a convention to take work done by the system to be negative and work done on the system to be positive. So due to those conventions, work is negative or positive, but overall work is said to be a scalar physical quantity. It follows a simple algebraic additions. Also, the multiplication of such physical quantity follows a simple multiplication rules. Okay, like if you want to multiply like work, okay, work, and if you want to divide it with time, then we have to just do a simple division or multiplication. It doesn't require any special multiplication or division. Whereas in vector physical quantities, both direction and magnitudes are required. They may be positive, negative or zero depending on the conditions given. They need a vector addition. They cannot be added with simple algebraic addition. They need vector addition. Those vector addition are of two types. One is law of parallelogram, LOP, law of parallelogram, and another is law of triangles. Okay, we will be discussing this thing in our upcoming lectures. Now, some examples I have given. Position is a vector quantity. See, if I say my house is like 2 kilometers from the center of Ahmedabad, suppose. Okay, my house is 2 kilometers away from the center of Ahmedabad. Will you be able to find out my house? So if you think, you will not be able to find out. Why? Because from the center, in which direction I have not mentioned. So position is a kind of vector quantity. Okay, it requires both direction and magnitude. Again, if I say my house is in the north direction from the center of Ahmedabad, then also you will not be able to find out my house. Why? Because north direction, how much magnitude you have to go in the north direction I have not specified. So such physical quantity are called vector physical quantities. Okay, so similarly, displacement, velocity, acceleration, momentum, force, torque, angular momentum, electric dipole moment, magnetic moment, area, etc. There are such many more physical quantities. You have to think yourself whether the direction is required or not. On the basis of that, you can decide whether a physical quantity is scalar or vector. Okay, so thank you. In upcoming lectures, I will discuss the multiplication and addition of vectors. Okay.